Morning. Welcome to my stream. It's a Monday, so I hope everybody had a great weekend. What I was doing last week was the roguelike. Let me switch over to my display here so we have everything up and running. I had been working on this roguelike here. We just finished up the chapter on toggle bit. Thank you for the raid. I just started, so good timing. Thank you. So last week we had worked on magic items and on the town portal stuff, and then I said, okay, you know what? This week we're going to change things up a little bit, and we're going to work on crafting interpreters. We're going to port this to Rust. You got diamonds, yeah. Thanks again for the toggle raid, and thank you Zeta Numbers and DJ Valor and Lucas Ig11 for the follows. Much appreciated. All right, thanks again. Oh, stream title use HTTPS. Yes, let me do that. Good idea. I don't know why. I did a copy over here, copy paste. I don't know why. Oh, because it's not secure. Let's see if we can switch it over to HTTPS over here. Yep. Okay. Thank you. Thanks again for that. And updated. Okay. Spuckseye, thank you for the follow. And Epic Dick Zetbauer. Okay. Epic Dick is a way they used to encode characters before ASCII, or maybe it was during ASCII times too. It's just a weird way of doing it. The numbers all kind of wrapped around this way instead of right to left. It was kind of weird, but it worked for them. Right, so we were going to start with crafting interpreters. We're going to get into trying to figure out how to write an AST, and then how to write a bytecode virtual machine. Not all today, obviously, right? And it's going to take us a while to get through, at least me. I'm pretty slow at this sort of stuff, and I'm still a beginner at Rust, so there may be things that I get stuck on, which will be fun and interesting. So let's start right here with welcome. Well, I'm not going to read the dedication or acknowledgements, but we can go to the welcome. This may be the beginning of a grand adventure. Programming languages encompass a huge space to explore and play in. Plenty of room for your own creations. The book will give you a guided tour, and we'll also get acquainted with Locke's language. I'm not going to read every word on every page, especially pages like this, because this is supposed to be a coding stream, not a reading stream. But why don't we start off by just creating a new repo. Here's my repos. Let's create a brand new repo here. Locks. Call it Locks AST because it's the AST version of Locks interpreter in Rust. Here we go. Sure, let's do that and that for Rust and MIT. I mean, I don't own the language, but I will own the code. So Zeta numbers. Yes, I am just starting. Epic Dick says a significant bit of the charter code is safely protected in the center of the reel-to-reel tape. Is it? How about that? I did not know that. VMT Tiv says, can you do dramatized docs reading a la BeginBot? I'm not familiar with BeginBot, but I can read things in a dramatic way. I have had a lot of practice reading books to my kids when they were younger, so I could say, I'm really excited. We're going on this journey together. This is a book on implementing interpreters for programming languages. But I think that would get very old very fast. All right, so let's clone this guy. Oh, thank you for the follow, VMT Tiv. Let's copy this, and I think I just call it git. I've changed up my config so many times I keep forgetting. Oh, GitHub. Okay, git clone. It's just GitHub. There we go. Okay, cargo run. Oops. Oh, right. I have to. It's a new new Rust thing, but now it's. I don't know how to create a cargo. And this one's just called locks AST. I don't know how to create a Rust repo inside an existing repo, except by hand like this. Oops. What did I do? What's broken here? Oh, yeah. That's why. Come on. Let me in. Pub on main. Println. Let's just make sure this is all working. Okay, so everything's going. Oops, cargo run. There we go. In ASCII, if one side of the tape is damaged, it's hard to get the data back. Yeah, well, I mean, if you store your data on tape in a non-redundant fashion without error correction, that's your own fault, isn't it? Okay. What am I looking at here? Oh, this is my rogue stuff. Okay, yeah. So in these pages, we walk step by step through 2 complete interpreters for a full-featured language. Right. I assume this is your first foray into languages. Not really, but it's been long enough that I need to learn. So I'll cover each concept and line of code you need to build a complete, usable, fast language implementation. Now, the first one is in Java, and there are things in Java that are done for you under the covers that Rust doesn't do. So we're going to have to implement more than what they're asking us to do. And the version that's in C, I'm assuming, is going to be close to Rust, right? I don't know if we should do that one first then, but languages are a great exercise. Here's reasons to do it, right? Last reason is hard for me to admit because it's so close to my heart. Ever since I learned to program as a kid, I felt there was something magical about languages. When I first tapped out basic programs one key at a time, I couldn't conceive how basic itself was made. Right, so learning how languages get parsed and interpreted is interesting. So we're reading the first part now, just the intro. Eric Dick says, I'll let the 70s know your disapproval, jumping between Java and Rust too. Okay. I don't disapprove of Epic Dick. It's just weird. It's a weird layout. So we're talking about crafting interpreters, so the book contains real code. That's good, because it would be hard to port it if I didn't have code to port from. Code doesn't have many comments. It's because each handful of lines is surrounded by several paragraphs of honest-to-God prose explaining it. So we should probably comment all the code. It would be nice if we could do like test-driven development. I don't know if that's going to be possible, depending on how this is all set up. Since the book contains literally every line of code needed for implementations, the snippets are quite precise. Also, because I try to keep the program in a runnable state, even when major features are missing, sometimes we add temporary code that gets replaced in later snippets. All right. So if the program's always going to be in a runnable state, we should be able to write a test and then add the change that makes it, right? Each chapter ends with a few exercises. Okay, unlike textbook problem sets, which tend to review materials you've already covered, these are to help you learn more than what's in the chapter. They force you to step off the guided path and explore on your own. Vanquish the challenges and you'll come away with a broader understanding and possibly a few bumps and scrapes. All right. Or skip them if you want to stay inside the comfy confines of your tour bus. All right, so the first interpreter is going to be written in Java. It focuses on concepts. Java is a great language for this. It's an OO language. That paradigm swept the programming world in the 90s. Now it's the dominant way of thinking for millions of programmers. And Java is hugely popular. By the end of part 2, we'll have a simple, readable implementation. It's not very fast, but it's correct. However, we are only able to accomplish that by building on the Java virtual machine's own runtime facilities. We want to learn how Java itself implements these things. So in the next part, we start all over again in C. VMTTIV says Java is a great language, Sun Microsystems. Did they ever say that? I mean, it is a good learning language, right? It teaches you a lot of concepts. I have a child in high school now, and they're using Java for their for computer science AP exam. So, I know there's haters. Big reason you're using C is so I can show you things C is particularly good at, but it doesn't mean you'll need to be pretty comfortable with it. I do C in my day job, so I don't think I'll have a problem understanding how the C is going to work, and then we can just port it to Rust. All right. Oh, we'll even try our hand at benchmarking and optimization. All right. Okay, well, we'll do that. So how do I get to the next page here? I scroll to the top. Oh, here it is. Scroll to the bottom. All right. So we're talking about how. Okay, so you go from the source code, you scan it, create tokens, you parse it and create a syntax tree. You go through analyzing, or this is interesting. Transpiling gets to a high-level language, so you can convert it from LOX to C or to Rust or whatever. Or generate bytecode, or generate machine code. At some point, here, treewalk interpreter. So I think this is what we're doing for the first part. I was going to create the abstract syntax tree and then generate a treewalk interpreter. I understand how scanning works. We take a string of bytes, right, which is just individual characters, and then we put them into symbols. And I need to put a dislike on this particular track. Excuse me. Here we go. Monty Avocado, thank you for the follow. So we generate the tokens, right? We generate tokens from a string of characters. The next step is parsing. So we take the series of tokens and convert it into this tree. Var average equals min plus max over 2, semicolon. So we have a min plus max, we divide that by 2, and we get the average. I'm just looking at these labels here, expert.variable, expert.variable. I'm not sure what syntax that is supposed to represent. Parsing has long, rich history in computer science that is closely tied to artificial intelligence community. Oh, all right. We flawed humans still manage to use these simple grammars incorrectly, so the parser job also includes letting us know when we do by reporting syntax errors. And then we have static analysis. First two stages are pretty similar across all implementations. Now the individual characteristics of each language start coming into play. At this point, we know the syntactic structure of the code, things like which expressions are nested inside which, but we don't know much more than that. In expression a plus b, we know we're adding a and b, but we don't know what those names refer to. Okay, so then we're talking about binding. So every identifier has a binding for the variable. So that's where scope comes into play, a region of source code where a certain name can be used to refer to a certain declaration. So we're gonna have to deal with scope. Every function in LOX will have its own scope, and it might have subblocks with its own scope. Are we going to do anything more complicated than that? I don't know yet. If a language is statically typed, this is when we do type checking. Once we know A and B are declared, we can also figure out their types. And if those types don't support being added to each other, we report a type error. The language we build in this book is dynamically typed, so we'll do type checking later at runtime. Okay. So then we're talking about the back end. No, sorry, we talked about the front end, but apparently there's a middle end. Later researchers invented new phases to stuff between the two halves, the front and the back. So we have a middle. Right, so this intermediate representation. So this is probably where the AST comes into play. This lets you support multiple source languages and target platforms with less effort. Say you want to implement C, Pascal, C, and Fortran. You want to target x86, ARM, and Spark. So you'd have to write 9 full compilers for every combination. But if you compile it into an intermediate representation, and then you can just generate the source, the machine language based on the intermediate representation, which makes sense, right? You're adding a layer of indirection, which allows you to get a little more powerful. It slows things down, right? Because you're not going directly from Pascal to x86. You go from Pascal to intermediate to x86. So you're giving up a little bit of speed for a lot of flexibility. Once we understand what the user's program means, we're free to swap it out with a different program that has the same semantics, but implements them more efficiently. We can optimize it. A simple example is constant folding. So you have this constant here, and you can just calculate it during compile time, and then just assign it right there. And that's pretty common in modern compilers now. I don't know of any modern compiler that doesn't do constant folding. Many successful languages have surprisingly few compile time optimizations. Lua and CPython generate relatively unoptimized code and focus most of their performance effort on the runtime. And then here's a whole bunch of extra additional optimizations that you can do that are very common. And then we have code generation. So this is where the back end comes into play. We take our intermediate representation and generate a machine language. Right. Back in the old days in Pascal, when talking about the 80s, Pascal generated this thing called P code. The Pascal compiler for the Apple II generated P code that got interpreted then. Which we call bytecode today, apparently. And then the VM, right? So we're going to write a VM. So I'm just scanning a lot over this a bit because there's a lot to read. So we covered every possible phase. We have single pass compilers. So some simple compilers interleave parsing, analysis, and code generation. So they produce output code directly in the parser without ever allocating any syntax tree or other IRs, intermediate representations. These single-pass compilers restrict the design of the language. You have no intermediate data structures to store global information. It means as soon as you see some expression, you need to know enough to correctly compile it. Evictic says Acu COBOL does the same thing. Does it? Let's go take a look. I've never programmed in COBOL, so I don't know what the various options are. Oh, interesting. We can say single pass. Oops, typoed the pass. Yeah, as a single pass compiler produces an object file. All right, thank you. Where was I? Here we are. Treewalk interpreters, which is what we're going to do for part 1. Some programming languages begin executing code right after parsing it into an AST. To run the program, the interpreter traverses the syntax tree one branch and leaf at a time, evaluating each node as it goes. This implementation style is common for student projects and little languages, but is not widely used for general purpose languages since it tends to be slow. Some people use interpreter to mean only those kinds of implementations, but others define that word more generally. So treewalk interpreter, and then we have transpilers. So you write your front end of for your language, and in the back end, instead of doing all the work to lower the semantics to some primitive target language, you produce a string of valid source code for some other language that's about as high level as yours. Then you use existing compilation tools. Right. So you take locks. Yes. Hi, Delup. How are you? I don't have any bang commands in my chat. That's something maybe we could do as an alternative to this. Is write a little bot. That would be fun. I know people like to do that, and that could be a lot of fun. Web browsers are the machines of today, and their machine code is JavaScript, and now it's becoming WASM, right? WASM seems to be getting a lot of traction, and in fact, in my little roguelike that I've been developing, this is all run in a browser using WASM, not JavaScript. So there we go. So just-in-time compilation. And Dayloop, there's a link in the stream description for the site I'm looking at here. Right, and then JIT, which means we convert it as we convert it into something that executes faster as you get to it. The most sophisticated JITs insert profiling hooks into the generated code to see which regions are the most performance critical and what kind of data was flowing through them. Then over time, they will automatically recompile those hotspots with more advanced optimizations. This is, of course, exactly where the hotspot JVM gets its name. All right, so this is all good. Let us get to we'll have a description of the language. I do want to get to some code today. But this is what locks looks like. Print hello world. That looks pretty straightforward. So we have a double slash for line comment. Lock syntax is a member of the C family. What C-like syntax has is instead of something you find more valuable in a language familiarity. Yeah, so it'll be easy for people to learn. Flappy, hi, how are you? Thank you for joining the stream. This book ended up bigger than I was hoping. It's still not big enough to fit a huge language like Java. Right, so we're going to use a smaller locks language. Locks is dynamically typed, we learned that. There's still plenty of reason to like static types, but they don't outweigh the pragmatic reasons to pick dynamic types for locks. And then automatic memory management. Two main techniques for managing memory. Let's see how locks is going to do it. Reference counting and tracing garbage collection. Ref counters are much simpler to implement. That's why Perl, PHP, and Python all started out using them, but over time the limitations of ref counting became too troublesome. All those languages eventually ended up adding full tracing garbage collection, or at least enough of one to clean up object cycles. Tracing garbage collection has a fearsome reputation. It is a little harrowing working at the level of raw memory. Debugging a GC can sometimes leave you seeing hex dumps in your dreams. But remember, this book is about dispelling magic. So what are we actually going to be doing? I think you'll find the algorithm is quite simple and a lot of fun to implement. Okay, so I guess we're doing a garbage collection. J-Dog says, did you already work through this book with another language or first time? This is my first time. So I thought I'd just dive in the deep end, right? The first one's written in Java, but I know Java pretty well. And the second half is written in C, and I know C very, very well. So the part I don't know is Rust. So I'm still learning Rust. We'll figure it out as we go along. And like I said at the beginning, I probably will get stuck more than once trying to figure out how to translate a concept from Java to Rust or from C to Rust. So we're going to have Booleans, numbers, strings, and nil as our data types. Okay. And then we have expressions. These are going to all be standard expressions: add, subtract, multiply, and divide. Comparison and equality. Okay. We have logical operators. We have bang, and or. Data number says you will like Rust if you were C++ dev at some point. I was never a C++ dev. I tried playing around with C++ a bit, and I didn't care for it. It didn't really work well in my brain. So, like I said earlier, my day job is C programming. So I'm happy to take concepts from C or Java and go from there. But C++ is not... All right, so we have precedence and grouping, right? So we're going to be doing that. That's good. JDog says, how determined are you to finish the whole book? I want to. I mean, that's the reason I'm doing this stream is so that I can finish the book. If I end up not being able to finish the book because I'm stuck on something, I'll probably go running to Togglebyte and ask for help. I didn't think that was the plan until I just said that just now. Or the Rust Reddit. Maybe people on Rust Reddit would. I also imagine I'm not the first person to try to do this in Rust, so there might be other repos out there which have Rust implementations of this. Zeta Number says, I'm speaking from my own experience. Okay, so you used to do C++ back in the day, and you like Rust now? What do you do for work? Are you a programmer? All right, so these are statements. These are variables. We have ifs and whiles for control flow. Oh, also for loops. Good. I left do while loops out of locks because they aren't that common and wouldn't teach you anything that you wouldn't already learn from while. Go ahead and add it to your implementation if it makes you happy. It's your party. Rust also leaves do while loops out, doesn't it? The difference between while and do while, for those who don't know, is the do will always execute at least once, whereas a while can execute 0 times if the condition is not met. Zen Punk, thank you for the follow. Dayloop says, I too come into Rust with a good idea of C++. So hopefully, Dayloop, you like Rust as well. And then Zeta Number says, Rust has loop loops also. They are enough for anything really. Yeah, loop. So it's an infinite loop, right? Let me just pull up main again here. So it doesn't do. Yeah, see, do is highlighted like that. So one while x less than 4 or something like that, right? This is a stupid example, but in Rust, apparently do, my Vim is telling me do doesn't exist, or it's reserved, so don't use it. So this exists in C and probably Java. I don't remember. It's been a while. But in Rust, you have to put the while at the front, which means it'll check the condition first. Whereas if you have the do here, it'll execute this first and then do the condition. So if I said it, let x equals 5, then u gets incremented even though x is not equal to 4, not less than 4. And then Zeta Numbers is saying loop. Yeah, so you can do loop. And then at the bottom of the loop, you say if x less than greater than or equal to 4, break. Right? And that gets you your similar semantics, although continue in here would, a do while, we could check the while condition before continuing, whereas a continue here just restarts the loop without checking the condition. So there's semantic differences, and you have to, but really, you can do everything you need to do with while, right? You don't actually need for loops. You can just do everything with while. Zeta Number says you need to use if something break value. Yeah, okay. Yep, agreed. All right, so we're going to have functions. This is good. I like functions, and they're called fun, which makes them fun. I've seen languages that use fn, fun, func, and function. I'm still hoping to discover a functy and a functio somewhere. Yeah, and then you have to start removing the f's. Saul, thank you for the follow. All right, so we're going to do functions, fun functions. Closures. Okay, very cool. Functions are first class in locks, which means they are real values that you can get a reference to, store in variables, pass around, etc. This works. So you can call identity with add pair in 1 and 2, which means add pair gets returned as a function, and then we call it with 1 and 2 here. So you can pass function pointers around. You can have local functions, which are scoped. I'm assuming they don't mention it here, but I assume that this is now scoped inside here. So outside outer function, you can't access local function. If you combine local functions, first class functions, and block scope, you can run into this interesting situation. So return function calls out, sets outside, defines an inner, returns the inner, which prints outside, which is within this scope, so we get outside. Christoph, thank you for the follow. Christophosaurus. Right, so here inner accesses local variable declared outside the body. Is this kosher? Now that lots of languages have borrowed this feature from Lisp, you probably know the answer is yes. For that to work, inner has to hold on to references, right? So this has to have access to that, to return that. So fn now is a reference to inner, or a variable which points to inner, but that has to have the ability to see this value outside. And of course, in Rust, you would say, it would tell you, oh, lifetime of outside doesn't exist beyond the return value of this function, or what's the word? It's borrowed. I forget what the error message is. It's borrowed past the lifetime, or the variable's dropped before the lifetime, before the return value. I forget exactly what it is. Eric Dick says free memory with defunct, and Zeta number says dangling reference. Yeah, well, I mean, somehow this gets through. Oh, and Flappy, thank you for the follow. I missed that. Yeah, for that to work, inner has to hold on to references to any surrounding variables that it uses so that they stay around even after the outer function has returned. We call functions that do this closures. These days, the term is often used for any first-class function, although it's sort of a misnomer if the function doesn't happen to close over any variable. Okay, semantics, right? Oh, classes. Since Locke says dynamic typing, lexical scope, and closures is about halfway to being a functional language, but as you'll see, it's also about halfway to being an object-oriented language. Alan, thank you for the follow. Since classes have come under fire for not living up to their hype, let me first explain why I put them into locks and in this book. There's really two questions. Why might any language want to be object-oriented? I don't know. Well, I think a lot of it is about more. I can't think of the term. Is just being able to keep everything in scope. Having defined behavior for objects. There was somebody who was telling me that it shouldn't have been called object-oriented programming, but message-oriented programming, because you're really sending messages between objects, and concentrating on the object side of the model was a mistake. I should try to dig up that talk. Zeta number says traits for the win. Yeah. So traits are, I guess, kind of mostly associated with Java interfaces, which are slightly different. Polymorphism. Thank you. Samara Gusto. Thank you. Yes, I was thinking of the word polymorphism, I was trying to think of that word, but I couldn't get it out of my brain fast enough. So why is Locke's object-oriented? I could claim objects are groovy, but it's still out of scope for this book. Most programming languages books, especially ones that try to implement a whole language, leave objects out. To me, that means the topic isn't well covered. That's a good point. Given how many of us spend all day using OOP languages, it seems like the world could use a little documentation on how to make one. As you see, it turns out to be pretty interesting, not as hard as you might fear, but not as simple as you might presume. That's fair. And then classes are prototype, right? So JavaScript is a prototype-based, oops, I clicked on it, trying to highlight it. It's a prototype-based language, and Java is a class-based language. So Epictic says computer scientists are bad at naming things. Yeah, I mean, there's how's it go? There's four problems, four difficult things in computer science. One is cache invalidation. Second is naming, and the third is off by one errors. Zeta number says message-oriented programming. That's quite an interesting point of view. I see. What's the point? I should dig up that talk. It was from about 5 years ago now, maybe. Somebody was giving a talk about it, and it's online somewhere. I'll see if I can dig it up after the stream today, and then look at, or maybe I'll tweet it, and talk about it in the beginning of tomorrow's stream. Right, so class-based language, there's two core concepts, instances and classes. Instances store the state for each object, and classes contain the method. Right, prototype-based languages merge these two concepts. There's only objects, no classes, and each individual object may contain state and methods. And objects can directly inherit from each other. And so instead of inheriting from a class, you inherit from other objects. So that means, in some ways, prototypal languages, interesting, are more fundamental than classes. They're really neat to implement because they're so simple. But I've looked at a lot of code written in prototypal languages, including some of my own devising. Do you know what people generally do with all the power and flexibility of prototypes? They use them to reinvent classes. Okay, and classes in locks look like this. Okay, so we have a class. We have then the methods within the class. When class declaration is executed, locks creates a class object and stores it in a variable named after the class. Just like functions, classes are first class in locks. For some variable breakfast, pass it to functions, some function breakfast. So I assume you can say some variable dot something, right? Oh, okay, so some variable is actually a class variable, whereas this is an object variable of an instance of breakfast. I see, with the syntax with the parens instead of without the parens. I get it. Classes that only have behavior aren't super useful. So you need to add fields. Locks, like other dynamically typed languages, lets you freely add properties onto objects. Neat. Assigning to field creates it if it doesn't already exist. If you want to access a field or method on the current object from within a method, you use the good old this. What if it's not defined? What happens? Part of encapsulating data within an object is ensuring the object is in a valid state. You can define initializers. And then inheritance allows you, using a less than operator, you can inherit. Here, brunch is the derived class. Breakfast is the base class, and every method defined in the superclass is also available to its subclasses, okay? Even the init method gets inherited. And then you can call super init. Okay, that's very similar to Java. And then we're going to have a standard library. Oh, it's embarrassing. What's embarrassing? The saddest part of locks, its standard library goes beyond minimalism and veers close to outright nihilism, or nihilism. We only need to demonstrate the code is running and do what it's supposed to do. For that, we already have the built-in print statement. So we're not going to have a standard library for locks, which means no hash maps, I guess. No boxes, no vex. Want to turn locks into an actual useful language, the very first thing you should do is flesh this out. String manipulation, trigonometric functions, file I/O. Heck, even reading input from the user would help. Oh, so we can't even do that? All right, don't worry, we'll have plenty of exciting stuff in the language itself to keep us busy. Yeah, I'm not worried about the busy, but I'm worried about the usefulness. All right, so here we go. We're going to start with the treewalk interpreter. And this is where we get here. So I'm going to quit out of this. We're going to do JLocks first. Implementing an interpreter uses a few architectural tricks and design patterns, uncommon in other kinds of applications. So we'll be getting used to the engineering side of things too. Okay. Given all that, we'll keep the code simple. And in less than 2,000 lines of clean Java code, we'll build a complete interpreter. All right, so let's see if we can figure out how to do scanning. Oh, okay, so we're diving straight into the code. This is good. First step in any compiler or interpreter is scanning. The scanner takes in raw source as a series of characters and groups it into a series of chunks we call tokens. Oh, Dayloop says also understanding requirements. I mean, given the fact that all the code is written here, I think we'll cover the requirements, but I'm just trying to think about, because if we're porting this to Rust, what is this going to do in terms of, because we're going to have to interpret the requirements from this and get them into the locks version and say, okay, there might be something in here that's done in Java that we have to rework completely to get it to work in Rust. And we have to infer some of the requirements based on that. Scanning is a good starting point for us because the code isn't very hard, pretty much a switch statement with delusions of grandeur. It will help us warm up before we tackle some of the more interesting material later. By the end of this chapter, we will have a full-featured fast scanner that can take any string of locked source code and produce tokens that we feed into the parser. Okay, so if we get through this chapter today, that would be good, right? And we'll have something that generates tokens. Since this is our first real chapter, before we get to actually scanning some code, we need to sketch out the basic shape of our interpreter. Oh, that was in reference to naming things, Dayloop. I see. Yeah, cache invalidation off by 1 errors. Yeah. And understanding requirements is that's a program management issue. If you dive into computer science, though, naming things is hard. All right, so we're going to start here. We have a main, which apparently either calls run file or run prompt. So how do we do this in Java? I mean, in Rust, this will be pretty simple, right? We have to get args, right? It's standard env args, I think is the way to do it. And then you just call args and get those. Something like that. Should we do clap? Should we use clap? Yeah, end of args. Okay. That's just an iterator. So we can actually just... I wish there were a... there's nothing up here that allows me to switch this into dark mode, is there? Okay. I'll leave it. Scanning fo. All right, so all we need to do here is say, this is, we can do collect, right? Can we do that? Or is it going to complain? No, it works. So we can say now if args len is greater than 1, println usage. I can't say jlocks. What are we calling it? Locks AST script. So that's pretty straightforward, right? And else if args len is equal to 1, run file. I guess we can make a, and we're going to use snake case for this. Else run prompt. So they were talking about having things in compilable states, but we can't have a compilable state right now because we don't have run file or run prompt. Zeta number says, I use darkreader.org to convert white theme sites into dark. It's pretty good at doing that? Okay. Well, let me see what that looks like. If I do here. Oh, I see. It's a little extension. All right, I'll take a look at that off stream. arg0 should be the name of the program still. Probably. In Java, I guess not. But let's find out. Oops. Bang goes over there. Args. And then I can stub out these two guys. Oh. Like that, and then run prompt. Come on, there we go. Oops, I forgot args. Oh, it doesn't like that because value has a type string which is not implement. And I hit F1. Wow, I've started off really well, didn't I? Yeah, so arg0 is, you're right, Dayloop, thank you. arg0 is the name of the program. So we need to pass in args of 1 here, and that means it has to be 2. All right, so I should be able to say cargo run and get the, oh, I panicked because I failed to write run file, which is here. Stick that in a text file and go get your IDE or makefile or whatever set up. I'll be right here. Okay, LOX is a scripting language, which means it executes directly from source. Our interpreter supports 2 ways of running code. If you start JLOX from the command line and give it a path to the file, it reads the file and executes it. So that's this thing here. All right, run file. And here's where I say Rust read file bytes. Oh, I see. We have to pass in a... I guess reads all the bytes until EOF from the source, placing them into buff. Okay. So we can say let mut buff is vec new. Can we infer this? And then we can just call read to end. Use standard IO read to end. Oh, we need to generate a file. Oh, this is the read trait. So we need something that implements this, right? Yeah, so we do file open like this. Okay. And we need all of this stuff here. Use standard IO read file and buff reader, probably for the trait, right? And then standard fs file. And we can just say file open of, let's use the same parameter name we have here, path. And then we'll do this. Tomio, thank you for the follow. Let mut reader is buff reader new F. There's probably an expect in here, right? Oh yeah, there's a question mark. Expect cannot open file. And then we have the buffer, which is vec new, and then we just say reader read to end of buff. Okay, then once we have that, then we're going to call run, which doesn't exist yet. And it converts it into a string of bytes using the default char set. Can I just pass in the buff like that? And then I guess we're going to have run here, which takes a vec of U8. I see it down here, source. Right? Does that check? Nope. Oh, did I get that wrong? VMTdiv says, fun fact, argv0 is not guaranteed to be a non-null in POSIX. It's valid for argc to be 0. Okay. That's good to know. What did I do wrong here? I didn't like file. Oh, it's just those two guys. Okay. There. Okay, so that's that. Now we have run prompt. And this throws IO exception. This throws IO exception. So maybe I should be returning a result here. That would be the rusty way to do it, right? And there is a, yeah, IO result. So let's use that. And then we'll have to do an expect over here instead, right? And maybe get more complicated later. We can create our own result type. Looks like I'll need, so how do you do it without anything? Is there a way to combine these two statements together? Oh, I have to put an OK here. Yeah. If there's a way to combine these two statements, that would be good to know. All right, so that's that. Self, you think self might work? That would be good. Both the loop and zeta number say self. Perfect. Thank you. That's a new usage of self for me, so I appreciate that. Then run prompt. We get an input stream reader, a buffered reader, and then we do this. So how do we do this in Rust? Is we have to use standard in, right? Rust read lines from standard in. Looks like I've done this before. Oh yeah, here's self. Look at that. And so we can just add buff read, right? And then we can say, let's stand it in, stand it in. Is this gonna need to throw something? And then it's doing a lock for line in standard in lock lines. And then we do, what do we need to do? Oh, we have to print a prompt. Right, but we don't want a carriage return yet. So we have the line, if line is empty. It's the way to do it in Rust, then break. Otherwise we're gonna run. And now the line has to be converted into something, right? Because it's currently a string or something. What type is line at this point? The way we can do that. Oh, this is a result string. So we have to say unwrap. Or we can say if let some line equals line. And then we can say line is empty. Else break. Right, if there's no more input. Oh, okay. There we go. But we want to see what type it is, right? So what type is line? It's a string. So can we do string as bytes? Does it have? It does have an as bytes. Huh. I did not know that would work. That was a total stab in the dark. Okay, now we have run. So we're going to call our scanner, which doesn't exist. Let scanner is equal to scanner of source. So I guess we're going to have a source That's our thing, and then we can call, and list token is just going to be a vec of tokens, which tokens don't exist either. So tokens, I guess we just say scanner, scan tokens, and that'll have to return a vec of tokens for token in tokens, println token. So we'll just debug out it. So that's our whole scanner. I mean, yeah, we don't have scanner yet, but we'll add that. It's not super useful yet since we haven't written in the interpreter, but baby steps, you know? Right now it prints out the tokens our forthcoming scanner will emit so that we can see if we're making progress. Okay. While we're setting things up, another key piece of infrastructure is error handling. Textbooks sometimes gloss over this because it's more practical matter than a formal computer sciencey problem. But if you care about making a language that's actually usable, then handling errors gracefully is vital. Zeta number says, why would you pass the source as bytes? Because it's shorter than chars? Do you think we should do chars? Because we open this file here. We're doing this. Buff reader new is going to be passing in. I mean, if we look at this, I think read to end reads it in as bytes, right? So I want to have a single function here which gets this array. So it's either going to be coming from run file here, or it's going to be coming from run prompt here. So I went to bytes because this is already bytes. What you're suggesting though is doing this. Yeah, expected stir found vec, and that's on line 24. So read to end would have to convert this to a stir. I don't know if you can do that on an array of bytes. Yeah. There's an as pointer. So how would you, if we wanted to make this into a stir, how do you convert this into a stir? Rust convert byte array to string. You're saying just remove it? Yeah, it's saying here. So I need to convert this vector of U8 into a string. Oh, I can just say from UTF-8. Okay. What doesn't I like about that? Expected stir found results. Oh, and I have to unwrap it? Okay. You're saying read to string. Okay. From the path. So all this goes away. Oh, and then I hit F1 again. And then I can just say run. Oh, I have to assign it. Just something here. Rust read to string. It does return a result. So we can say if okay file, I guess, or buff. Get rid of all that, and then we can just say run buff. Nope, that got even worse. Oh, if let. And then this is mismatched because this has to be Esther. There we go. Okay. Question mark is used to propagate the error, right? But now I'm just destructuring it, and then we can just, I guess we could say else here. Let read in. And then run like that. Yeah, okay. So use question mark to propagate the error, and now we just get it like that. So that simplifies things. Okay, I like this. Thank you for the help. What else we got? So now we're going to talk about error handling. And now we have static methods here in Java, which is very different to, I mean, what we've been doing is static, right? Yeah, these are all private statics. But what I'm seeing here is now we're actually changing a global variable, which is not something Rust is fond of. So what's the right approach for this? I was thinking, okay, well, why don't we create a locks struct, which has a had error in it, and then we'd have to pass that around. We'd create error and report. Here's what I'm thinking, but I don't know if this is the best approach. We say struct locks had error bool, because I imagine this is not going to be the only thing that's going to be a global, and then impl locks. And this is a static method, right, to handle static variables, but we don't have that in locks. I mean, in Rust. Zeta number says you return result success type error type. Yes, that's true. I no, I agree. That's where we're going eventually. But turning on a flag saying that there's an error looks like this is part of the way that we do error handling. All right. So as we're parsing through the locks code, at some point we reach a point where we got a syntax error, for example. So we need to set a flag saying stop parsing. Or, you know, I've parsed as far as I can go. There was an error in the parsing. Don't try to run it because I couldn't interpret it all the way. And I think this is what this flag is for. So we need to be able to set that flag and then clear the flag for the next time. Like if they're running at a run prompt here, and they type in some bad line of code, we want to set the flag after we're done scanning or parsing, and then clear the flag before we do it again. So I'm thinking something along these lines, but I don't know if this is right. And then we have int line and string message. And then we call something called report. Data number says, doesn't seem like a good idea. I think this flag is for C-like error handling. Well, we could ignore it for now and see what happens. And then at the point where we have to set it, let's take a look at where we have to set it. Yeah, so it's a static, so it's a global variable basically. Hi Supercuber, how you doing? Yeah, so we're setting this flag and then then indicate an error in the exit code, or clear it here. Yeah. So right. So if we're running up here, okay. So I think what you're suggesting is just take a look at this. We could say match run And then if it's okay, something, then we're done. Otherwise it's an error, and then we should report the error here. Right? I think that's what you're getting at. Supercuber says, I wonder why it's static and not on an instance of locks. Yeah, that's a good question. I wonder if he had thought about creating a locks as a, you can create multiple lockses and have each one running in its own thread or something. And Zeta number says, in Rust you need to match on result. Yeah, that's if we decide to go that route, right? Here's where we set it to true. So let's try doing it this way, since this is the Rust approach. It just means we're duplicating the code here, right? Because we have to do it here and here. And here, then we're going to say, okay, I guess we can give it a message. And then run is going to have to return an error, a result type. I guess string. Sure. And then you'll just say okay here. And then we can just say error. Although we probably should have a result type with the line number, right? Because that's what we care about, is this line number. Supercuber says you could look at how interpreters compiles written in Rust and do it in the wild. Yeah, but I'm trying to port this, not. But that's a good point. Why don't we? Can we create our own error type, which contains? I guess we can just call it locks error, and it'll have the line and a message. And we can just fill those in here. And we can just say, for now, right, we'll derive debug on that, and we're going to get back that from here. So we can just print it out this way. And then I guess we'll have an exit in a second. But if we look down here, so I guess we're not going to do this. We're just going to create an error which generates a locks error. Right, and then a report. So locks error, line message. We don't need this anymore. Okay, and then we have pubfun report, which takes a locks error. It also is containing a where. Oh, I guess we don't want where. That's highlighting it, like where is a keyword. Zeta number says, usually people read the Rust book before writing anything. I don't want to make it harder for you. I'm just giving some advice. I have read the Rust book, and I've been doing Rust for a few months now. Yeah, I'm not sure. So Supercuber says you could use column maybe. I'm not sure what the where is meant to be. So I'm just scanning this with my eyes here, as opposed to my nose, I guess. We need to give the user all the information, right? So we have a report helper function. So error unexpected comma somewhere in your code, good luck finding it, or we could say unexpected comma in argument list. Yeah, so I'm not sure what the where is meant. They're not explaining what where is. Yeah, Rust does this, right? Where you actually point to the location. All right, so let's just do it this way, and we can just say eprintln. Oh, they're just doing regular println. Interesting. So we could just say line. Oh, I can't do it that way. I was going to do it with the new syntax, but I can't. Error. There, colon, space, and then message. Right? So error line, error lock, and error message. So that means up here we want to call report. And I guess lock is going to be nothing. All right, I have it as a string. This seems sloppy to me, but okay. Takeout says, where's argument list in example? So so what they're showing is here is we have an unexpected comment and the argument list. So we're calling a function. Here's the first argument. Here's the second argument. And then there's an extra comma. Either they meant to add a third argument or they just typoed and threw in a comma there. And so it's saying there's an unexpected comma. But we're not implementing that level of detail according to this. Primary reason we're sticking this error reporting function in the main locks class is because of that had error field. It's defined here. We'll also use this to ensure we don't try to execute code that has a known error. Also, it lets us exit with a non-zero exit code like a good command line citizen should. Okay, we need to reset this flag in the interactive loop. If the user makes a mistake, it shouldn't kill their entire session, right? So here we can do a similar thing. I guess with one file we want to say standard process exit 65. I don't know why they're using 64 and 65 for these things, but there you go. Here we're going to do a match. We'll report the error, but we're going to continue. And then just ignore that. Okay, so that still works. We don't have this had error, so I'm wondering how we're going to handle that. Maybe we just propagate it up from here, right? So when scanner called scan tokens, maybe it needs to return a result with locks error, which means this needs to be pub, which probably means it needs to go in its own little class, right? Should we do that? Source error. Let's move that over here. And then we can, maybe these things should be part of it, right? Which means doing this, which means we want to say m.report that. Do I have this right? No, error generates a report. Okay. Yeah, no, I think I want to have it so we create an error, a locks error, and then report it separately. Some tools, Supercuber says, some tools have multiple error codes, so they use bits to represent information. 64th bit, I'm probably in something. Obviously, up to your decision. Yeah, I'm just gonna, right. So they have 64 if you have a, if you fail to, if you give it too many arguments, and then 65 if we had a scan issue here. So I'm just thinking when we call error, we're going to generate a locks error, but we want to return that up to the top, and then report actually prints it out. Whereas in here in the Java version, when we call error, it's going to report it immediately and then set the flag. All right, so we're gonna take it like this then, and see how this goes. I'm gonna need to say mod error and use error star, probably. This is m.report. Oh, there's still a problem here. What's the problem? Doesn't like m.report. This is associated function. Oh, yeah, duh. Self. Okay, I think we're good. We have a new locks error type, which will return from a scanner, I guess. We'll find out. Data number says process exit code won't unwind the stack. You probably should use panic message for convenience. This is going to exit the whole process, right? So I'm just trying to think of what effect do we want to have for the user, right? So if let's say locks is a legit scripting language and you write something with a syntax error, we don't want the Rust interpreter to panic, right? We would just want the locks interpreter, which was written in Rust, to report an error and exit. So I think I'm going to stick with this for now, and if it turns out this was a bad decision, we can always fix it later. The other reason I pulled error reporting out here instead of stuffing it into the scanner and other places where the error might occur is to remind you that it's good engineering practice to separate the code that generates the errors from the code that reports them. Okay. Various phases of the front end will detect errors, but it's not really their job to know how to present that to the user. In a full-featured language implementation, you will likely have multiple ways errors get displayed. You don't want that kind of code smeared all over your scanner and parser. Okay, so I think we'll stick with this. This seems good, and maybe the scanner can, I have the question mark here already for scan tokens. So let's see. With some rudimentary error handling in place, our application shell is ready. Once we have a scanner class with scan tokens method, we can start running it. Before we get to that, let's get more precise about what tokens are. Supercuber says, don't think it matters here. We don't have any resources open except memory. Yeah, I mean, we read the file. We're all done with the file. We don't have to, we're not shutting down sockets and things. Here's a line of locks code. Here, var is the keyword for declaring a variable. That 3-character sequence var means something, but if we yank 3 letters out of the middle of language, like GUA, those don't mean anything on their own. That's what lexical analysis is about. Our job is to scan through the list of characters and group them together into small sequences that still represent something. Each of these blobs of characters is called a lexeme. In that example line of code, the lexemes are var, language equals, quote locks quote, and semicolon. The lexemes are only the raw substrings of the source code. However, in the process of grouping character sequences into lexemes, we also stumble upon some other useful information. When we take the lexeme and bundle it together with that other data, the result is a token. It includes useful stuff like token type. Token type. Supercuber says, eventually you may want to replace message string with your own enum. Oh, this here. Yeah. So having different error messages and just returning an enum, and then we could translate them here. That's not a bad idea, because that would allow us to localize, have all the localization stuff in one spot, right? If we were to localize locks. Zeta number says, I think we should just panic on any internal error. I agree with that. Like if there's a bug in our code, we should panic. But if there's a bug in the code that we're interpreting, the locks code that we're trying to interpret, I still think we shouldn't panic. All right, so we have token type.java. Okay. And again, I'm going to make these snake case. Just follow Rust's convention, and then we'll have token type, and then it's going to have left paren, right paren, left brace, right brace, comma, dot, minus, plus, semicolon, slash, star. Supercuber says, especially since we may want to keep looping to read the next user input. Yeah, exactly. Bang. I'm going to get really good at typing the word equal here. Greater, equal, less, equal. Oh, string is already used, but I think it's okay because it's part of this thing now. We're just going to see it highlighted every time we use it. And if it doesn't work, we'll have to change it to something else. Or print, return, super, this true, var, while, and EOF. Okay. We'll have to mod it in main here so that we can do a quick check. Scanner still doesn't exist. Okay. But it was able to get token type. So this is the token type. So we're still on this colon sentence here. It includes useful stuff like token type, like literal value, like location information, right? Okay. You just have to keep that in mind as we read each one of these paragraphs. There are lexemes for literal values, numbers and strings and the like. Since the scanner has to walk each character in the literal to correctly identify it, it can also convert that textual representation of a value to the living runtime object that will be used by the interpreter later. Zeta numbers says, I would like assign an equals instead of equals and equals equals. Right. Yes, I know. That is a point of contention for language design, isn't it? Here, this should be a sign. Right? I'm going to keep it like this for now, but we can always change it. We can always change it later, right? So we have literal value, then location information. Back when I was preaching the gospel about error handling, we saw that we need to tell users where errors occurred. Tracking that starts here. You want this to be a sign, a single equal, and equal to be equals. Yeah. Yeah, that's not a bad idea. I'm tempted to do it. And then we just have to remember when we tokenize, which is coming up pretty soon, right? The only thing is, this is a single equal, and this is an equal. So we're talking about encoding the the tokens that we're looking at, right? All right. Well, let's see what happens. What's the worst that could happen, right? So now we have token. We have a new file called token, which is going to contain this stuff. I guess the literal value and location. Okay, yeah. So we have the token type. We have a string for the lexeme. That makes sense. We have an object, literal. So in Java, everything is an object, right? Zeta number says, I would suggest to use dot comments. I'm not that familiar with dot comments, and I mean, I know it's triple equal, right? And triple slash, and then you can add like test code in here or whatever. Let's get through this chapter, and then maybe we can comment up the code, because we're only this far, and I can only stream for another half hour. So this is taking longer than I thought it would. But most of it was reading, and now we're actually developing, so this is good. So let's create a token file, pub struct token, and it's going to contain token type. I can't use type, right? I can use t-type. I can use lexeme. I can use literal. This is going to be interesting, because how do we do this? Right, object is a base class for everything in Java, but there is no such thing. There is the any type, but I think that's a trait, right? Supercuber says, what does this mean even? Some tokens don't have a literal. Yeah, you're right. So this would end up being null, right? So maybe this needs to be an option of something, which I don't know yet. And then we have a line. That's the easy part. Yeah, so like the var, right? We talk about this. This doesn't have a literal. This has a literal. It's language. Maybe the literal. No, not. Maybe I'm confusing literal and lexeme. Maybe token should be an enum. Either a symbol or a literal or... Oh, I see what you're saying. Right, because, well, so if we say pub enum token, right, and we could say it's a literal, which contains, lexeme and literal value, and we still don't know what to call it here. Let's say option. It's no longer option, right? Because it's there. Or it's a, I don't know, keyword. And then we'd have token type, keyword, string. And we have to have the lexeme also. Like that. And what else would there be here? Oh, I did that wrong. That's an interesting way to refactor it. Let me keep going this way, and then we can, once we get the scanner working, maybe we can refactor things and get it working a more rusty way. Oops. So Zeta number says in Rust I would use enum variant fields equal and everything else. Okay. So if we say impl token, have new, which generates a token, and it's going to take in we still have to figure out what we're going to put in this thing here. What's an object? Do we just generate our own object? And have like a num F64, I guess, and then a stir with the string. And what were the other ones? It was nil and a boolean. I guess we could just say true and false. Can we do that? Like that. And then, oh, this has to be literal. And then line, usize. And then we just create it, token. And then toString, we have a toString, so I guess we should implement display. Rust implement display, like that. Impl format display for a token. FN format self. Oops. Oh, where's my? There we go. F. Oh, we have to use standard format to get that to be there. And then it returns a format result. And we just say write bang F. And then we're going to put in type. Plus a space, plus lexeme, plus a space, plus literal. See, this is assuming that the literal exists. I guess it would just say null, right? So self token type, self lexeme, and then if let sum lit equals self literal, we'll say oh, then we need, can I say derive? Can I say derive display? I don't know if we can do that. And then, what am I putting here? Oh, I'm just going to put literal, else, none. Like that. No, you can't derive display. Supercuber says you can't do that. All right, so then we're going to have to, it didn't complain, but that's because I forgot, I didn't put a mod token in there. Okay, so we'll have to implement display for this. Let's see what the error is first, so we get that. A mod token. Expected colon. Oh, pub enum. I meant that to be an enum. And for some reason I have an extra. Use crate token type. If and else have incompatible types. Oops. Expected enum object found string. Oh, yeah. So how do I say to display on an enum? Is there a function I can call here to print it? Because I want this just to be toString. Can I just do that? Yeah, okay, standard format display. Okay, perfect. So now all I need to do is implement that. Supercuber says I just derived a bug and be done with it. Yeah, I mean that's probably the best way to do it, right? It won't look pretty, but it'll get us past this particular thing. Although now this needs to be an object then. All right, I'm going to do it. So we just need this line here. And then we can just say right bang f comma. Oh, we're going to need to do this. Match self num x. We'll just say right f x. Oops. Can I do this? Oh, and then if it's a stir, we can just put it in quotes. Like that. If it's nil, true or false. Nil. And then this will just be true and false. False and, oops. True and false. I'm trying to type too quickly here. Supercuber says it's prettier than putting spaces between the fields. Oh, you mean just derive debug for, oops, for this guy. Yeah. I mean, maybe we'll need it anyway. Let's finish this off. It couldn't hurt because we'll probably need it for as we're trying to get this thing to work. Not found in the scope. Oh, I got a object colon. There. What's the other error? Oh, see, it still doesn't like this, even though I have. Oh, to string. You're all looking at my Rust code and saying, what is this guy doing? Oh, there's no display for this. What? I just added that. Trait debug is not for token type. Oh, for token type. Source token type. That's simple enough. There we go. Okay. Wow. Okay, now we have an object with enough structure to be useful for all of the later phases of this interpreter. Okay, but we also wanted to look at having this, right? Having an enum with all the different things that could be a token and having their own destructure. Let's get through this, and then we can talk, and we can take a look at doing this. Maybe in the next stream. I got 20 more minutes. Now that we know what we're trying to produce, let's produce it. The core of the scanner is a loop. Starting at the first character of the source code, the scanner figures out what lexeme the character belongs to and consumes it and any of the following characters that are part of that lexeme. Zeta number says this tutorial is not designed for Rust. Probably anyone would have some troubles with it too. Yeah, I think one of the main motivations for me to do this in Rust is so that I learn Rust. I'm still very much a Rust beginner, and this is forcing me to learn a bunch of things that I would not otherwise learn just making little toy programs in Rust. Or the other thing I'm actually doing to learn Rust is making this little roguelike. So I've got this roguelike going on. It's all written in Rust. It's kind of fun to play with, but all the code's written for me in Rust. So I'm learning, but I'm not learning as much as writing my own Rust from a spec, basically. Oh, Supercuber, thank you for the follow. Data number says, so fancy. It is pretty fancy, right? I mean, I got neat little things. I got a little cheat menu for healing up my health or going to the next level or whatever. It's kind of fun. And I'm going to alternate that, do some of this for a few days and then do some of that for a few days and then see what else I can play with. It's all about learning Rust. So once it reaches the end of a lexeme, it emits a token, and then it loops back and does it again, starting from the very next character in the source code. The part of the loop where we look at a handful of characters to figure out which kind of lexeme it matches may sound familiar. If you know regular expressions, you might consider defining a regex for each kind of lexeme and using those to match characters. For example, LOX has the same rules as C, so this would be a regex for matching an identifier. If you did think of regular expressions, your intuition is a deep one. The rules that determine how a particular language groups characters into lexemes are called its lexical grammar. In LOX, as in most programming languages, the rules of that grammar are simple enough for the language to be classified as a regular language. That's the same regular as in regular expressions. You very precisely can recognize all of the different lexemes for LOX using regexes if you wanted to. There's a pile of interesting theory underlying why that is and what it means. There's like lex or flexor designed expressly to let you do this. Since our goal is to understand how a scanner does what it does, we won't be delegating that task. We're about handcrafted goods. All right, so now we're going to create a scanner. So we're going to need token type. And we're going to create a class scanner, which is a pub struct in Rust. We have a source. Oh, what were we calling the source? Our source is just a reference to a string. So that's going to be painful. I don't want to do that. I don't want to do that because then we have to get talking about lifetimes. If I do this, right, now we're talking lifetimes. And then we have tokens, which is going to be a vec of token. Data number says, hope they don't ask us to implement regex. Yeah, that's I think outside of the scope of this book. And data numbers also says just do string. I agree, just do string, but we're passing in a reference to str here for our run. So we're gonna rejigger all that. Here we'll make this a string, which means that we have to convert this to a string, which looks like it's pretty simple. And this should be a string already, right? Is that going to check? It does. So yeah, we'll just do string there. That looks good. For learning, just clone and sidestep it, says Supercuber. I agree. Yeah, or just pass ownership, which kind of makes sense anyways. Let me think about that. If we want to give the whole string to the scanner, I agree that makes sense. Because we don't need that string anymore. Right? Once we've converted it into tokens, who cares what the actual string is? But now thinking a little harder about that, we're generating these lexemes. I guess we'd have to clone those as well. We're going to have to clone something along the lines anyway because we want to extract the string out of the lexeme. Why don't we try that? Except the only interesting thing is we don't need. Yeah, let me put this back to stir. We don't need the source in the scanner, right? We can just take in the string of characters and parse them out, and then just clone into the lexeme. Right up here, we can just clone into the lexeme and then generate the literals as we go along. All right, so let's see what we're doing here. Oh, yeah, we do. Okay, we do need to save it. Damn it. If we're going to do it this way, we do need to save it. If we just passed it in here, that would be different. But it looks like we might generate all the tokens All right. All right. It's back to strings. Source string. All right. This will probably be the easiest one. Zeta number says source clone. Yeah. I mean, we could. Impl scanner. Pub fun new. Oh, we're just generating it right in there. Okay, I don't care about the new. The constructor is just the constructor. So let's create our scan tokens, which returns a vec of token. Right, and I should be able to now just say vec new, and then pull this into main. And then see what breaks. Tokens. Huh. So all they're saying is pull in token type. They must have it organized slightly differently, right? Scanner doesn't like this. Question mark only. Oh. Scan tokens doesn't return a result. It should. Or locks error. Which means I have to pull in locks error. Did I call it locks error like that? I did not. What did I call it? Just error. And this is an okay result. And then scanner still doesn't like this. Cannot construct due to inaccessible field. Oh, all right. So scanner new. Otherwise, I have to make that field public, right? Pub fun new. Source string. Scanner. Scanner. Source. Missing tokens. Oh. 53 warnings. Oh, because we're not using any of the tokens, right? That's fun. So we don't actually want to return this. We want to return self tokens. Okay. That's annoying. Do I have to do it this way? Yes. Okay. Because we're going to scan into the tokens. Epic Blog says, this is awesome. I wanted to do this myself, but never found the time. Now I can watch you do it and stream instead. Okay. Well, I'm gonna lean on you, Epic, for help then, because I'm sure I'm gonna get stuck at some point where there's something in Java that I don't know how to do in Rust. But this is interesting. So the scanner is taking a source, saving it, right? Is basically being moved in here. Then we generate all the tokens, and then we return the tokens. Why is it being done this way instead of and this is going to be mutable, right? Because we're going to be modifying this tokens. Why can't we just generate a vec of tokens in here? Why do we have to? Yeah, see, this is just returning token. Why do we have this at all? Because it could all just be done in here. Unless you're, as we scan, maybe we push other tokens. I don't know. Oh, this just token. Oh, yeah, okay. So it's kind of a global thing. All right. So let's write this. So we say while not self is at end. I'm just copying from this here. Start equals current. Where's start defined? Oh, okay. current is usize and line is usize. And now we have to add those here. Start 0, current 0, line 1. Okay, so we're going to say self start equals self current, self scan token, and we're done. And then say self tokens push token. Can I do it that way instead? Because we're just generating a null token. Diablo, hi, how are you? Yes, on the left is Java, on the right is Rust. So there you go. Epic Blog says watching programming on Twitch is an endless stream of living vicariously. Yeah, you know, I feel like I'm such an awesome Rust programmer while I'm watching Togglebit streams. And then I try to do it myself, and I realize how much I have left to learn. So if we open up token, we can generate a impl token. Here we go, pubfun new. We can say pubfun uf, and just return a token of token. T-type is going to be token type EOF. The string literal is going to be to string. Oop. Literal is going to be none, and line is going to be, oh, the current line. So we need to pass in the current line. Easy peasy lemon squeezy. Line usize. There. I like that. Now we delegate the work out to token, and we don't have to know the internals of the token type here. Or the token struct here. Oh, Diablo says, I've been here since Toggle dropped us off. Okay, so you've been enjoying my struggles silently, snickering in the background, I bet. The scanner works its way through the source code, adding tokens until it runs out of characters. Then it appends one final end of file token. This isn't strictly needed, but it makes our parser a little cleaner. The loop depends on a couple of fields to keep track of where the scanner is in the source code. All right, so then we have is at end, and then, oh, okay, and we have scan token. All right, let me get these two. Oh, I was hoping we would have something that compiled and ran, but it looks like this calls advance, advance calls char at, increments current. And then we have add token, which is this, and add token, which is this. Will it run at this point? Because I'm out of time now, unfortunately. And this won't work because we don't have scan token. But I can just stub that out. Pubfun scan token self. Right? Oh, is at end doesn't exist. Maybe we can write that real quick. Current is greater than source length. Self current greater than or equal to self source length. Yeah, okay. So we have it in compilable form. We just stubbed out, yeah, we just stubbed this guy out so that we can come to him tomorrow. Diablo says, I've written parsers before, but not with Java. I've used Java before, but not to write a parser. Wrote a toy language with Lemon and RE2C before. You're mostly on the right path. All right, cool. Although I've never heard of or RE2C. With lemon, the parser calls lexer instead of the very odd lexer calls the parser structure that bison and flex use. Okay. I will definitely check those out. Ooh, this looks really interesting. Okay. I'm getting distracted. I need to call it a stream. Let's commit what we've got. Oops. Right? Git commit beginnings of a locks scanner. And we'll push this up. I haven't checked in with Clippy on this, but I'm not going to worry about it because there's a million errors, warnings, right? If I say cargo run, we have all of this stuff here, and then we panic because we're trying to scan an empty string. We shouldn't have panicked, though. We should have said, oh, you don't have an argument. All right, well, we'll fix that later. But yeah, so all of these variants are not being used. And that's where all the errors are coming from. And this associate function is never used because we're never calling error. Oh, well. All right, but we have an initial commit of very buggy, broken code. And we will call it a stream today. To next stream, yeah, we're about, what, almost halfway down this chapter. So we should be able to finish this chapter and do part of the next chapter for tomorrow. So I'm just going to call it a stream here. I wish everyone a great day. Hope you have a terrific day. I hope you enjoyed this. I certainly did. I really appreciate all the feedback I've been getting from various people in chat. It's been a lot of fun. And I will see you tomorrow with a little more of crafting parsers. All right. Take care, everyone.